7-2, Measuring Portfolio Risk. Risk is measured by the variability of annual returns from the average annual return. So let's say we're thinking about the market portfolio, the US stock market, and we wanted to look at its variance, which is sigma squared. How would we calculate it? We would take the sum of the differences between the expected return on the market, which you know is 11.3%, and the actual return in any given year. You square each of those differences, you add them all up, and then you divide by the number of stocks in the portfolio minus 1, which is called a degree of freedom. Once we have variance, sigma squared, we can calculate standard deviation, sigma, just by taking its square root. Let's calculate the variance and standard deviation for Apple Inc. over the 10-year period from 2012 to 2021. How do I do this? I go to the internet and I pull down the rate of return on Apple stock for each of the years 2012 through 2021. You can see that in what's labeled growth rate here. 31%, 5%, 38%, negative 5%, 10%, and so on. What are we saying? We're saying that in the year 2012, if I had bought Apple stock at the beginning of the year on January 1st, 2012, and sold it on December 31st, 2012, I'd make 31% on my investment in the year 2012. In 2013, I would have only made 5% of my investment if I had done the same things. Now, this accounts not only for the growth in stock price, but also for any dividends that are paid. This information is widely available just for a simple Google search on the internet. Now, we know that if we take a arithmetic average of these 10 years growth rates, we will get an average of 32%. If you're doing this calculation in Excel, you just use the average command. So if someone asked me, what do I expect my return to be going forward? I would say, 32%, because that's my average annual growth rate. All right, so I'm going to compare the actual growth rate in each year to the expected return, find the difference, square it, and that'll be my variance for each year. So in the year 2012, I take 32 minus 31 and I get 1. 1 squared is 1. Because of the rounding error, it's actually closer to 0. In the year 2013, I take 32 minus 5, which is 27. I square it, I get 706. Again, that includes some rounding error. Once I have my variances for each of the 10 years, I total them up and I get a total variance, which I then divide by the number of years. So take the total, divide by 10, except you don't divide by 10, you divide by 9 because it's a degree of freedom. You divide the total variance by n minus 1 years. Okay, and we get 1,065 for our variance. The units of variance are the same as the units of the growth rate squared. So if the growth rate is in percent, then variance is in percent squared. I then convert variance to standard deviation by saying the square root. So the units on the standard deviation, which is 33%, is percent, the same units as my growth rate. I can calculate variance for an individual stock. I could also calculate variance for a portfolio of stocks or a portfolio of bonds for that matter. This is the Dimson, Marsh, and Stanton study, Triumph of the Optimists again. We looked at the annual average rate of return for treasury bills, government bonds, and common stocks. Now we look at the standard deviation for each of these. Standard deviation and variance being a measure of the risk of these portfolios. Treasury bills had a standard deviation of 2.8%, government bonds a standard deviation of 8.9%, common stocks a standard deviation of 20%. Since we all earned more return on government bonds than we did on bills and more on common stocks than bonds, you'd expect there to be more risk in bonds than bills and stocks than bonds, and you see it. Standard deviation, the measure of variability, is the measure of risk for each of these portfolios, and common stock is by far the riskiest of the portfolios. How do we interpret a standard deviation for the common stocks, the US stock market, of 20%? Well, let's think of it this way. If I asked you, what's the expected return for common stocks next year? What would you say? You'd probably say 11.3% because that was the average annual rate of return for the US stock market for 110 years. I'd say great. I'd say, well, how confident are you that in fact it's going to be 11.3% next year? And you'd say, well, there is quite a bit of variability, variance or standard deviation or risk in the stock market. So here's what I can tell you for sure. If I take 11.3%, my expected annual rate of return, and I add 20% to that so that I get 31.3%. And if I take 20% from 11.3%, so that I get negative 8.7%, there's my range, somewhere between negative 8.7% and 31.3% is what I can tell you I'm most likely to get next year for the rate of return for the stock market. I can tell you that'll be the case 68% of the times because I took my range from one standard deviation on either side of the average annual return of 11.3%. If I wanted to go up to 95% of the possibilities, I'd have to go 2 standard deviations in each direction. A very important aspect of risk reduction is the idea that diversification within a portfolio reduces risk. Diversification within a portfolio reduces variability. Suppose you were to create your own portfolio of 10 stocks, 1 share of stock from each of 10 publicly traded corporations. Now, to find out the expected annual rate of return for the portfolio, just take an arithmetic average of the historical annual rates of return for the 10 stocks, and you got your average annual return for that portfolio. But to find out the expected annual standard deviation or variance for the portfolio, the calculation is more involved because diversification reduces portfolio risk, reduces portfolio variance. If you were to just take an arithmetic average of the historical variances of each of the 10 stocks in the portfolio, you would have an overstated portfolio variance because the diversification across the 10 stocks will reduce the portfolio's overall variance. That idea is captured by these graphs. Let's say I had $100 to invest in a portfolio of stocks and I chose to buy one stock and only one stock in my portfolio, many shares of this one stock. Well, maybe that stock has a standard deviation of 50%. Therefore, my portfolio standard deviation is 50%. But now I decide to buy 2 stocks. They are stocks from different industries. They both happen to have a standard deviation of 50%. So you would think the average standard deviation for the portfolio would be 50%, but you would be wrong because as long as these stocks don't move precisely in lockstep, which most stocks do not, there will be a benefit from diversifying across 2 stocks. In other words, my return will still be a arithmetic average of the returns of the 2 stocks. My risk or my standard deviation will be less than the average of the standard deviation of the 2 stocks. It looks like in this particular diagram, the 2 stock portfolio is going to get me a standard deviation for the portfolio something like 47% or 48%. Now let's say that I decide to buy a portfolio of 5 stocks. This portfolio has 5 stocks in it, and these stocks do not move in lockstep. They may all have individual standard deviations of 50%, but the portfolio standard deviation is not going to just be an average of those 5 stocks standard deviation. It's not going to be 50%. It's going to be far less than that due to the reduction of risk from diversification. It looks like for 5 stocks, the portfolio standard deviation is now 30% because there's been a major reduction in specific risk. What do I mean by there's a major reduction in specific risk? Look at the graph on the bottom right of your screen. You will notice, same graph, there is an asymptote, a horizontal asymptote. Everything below the asymptote represents market risk. Everything above the asymptote represents specific risk. The graph itself, that concave up curve, takes in a number of stocks and spits out portfolio standard deviation or portfolio risk. Portfolio standard deviation or portfolio risk consists of two components, always market risk and specific risk. Diversification will remove all of the specific risk in your portfolio. However, market risk can never be diversified away. There is a baseline amount of risk that cannot be diversified away. Our goal then in building a diversified portfolio of say at least 20 stocks, perhaps more, is to remove all of the specific risk from our portfolio. How wonderful. Our returns didn't get reduced by diversification, but our risk does. So everyone should have a diversified portfolio of securities.